Now I'm going to quickly demonstrate soldering into a circuit board type of application. Here's a diode that I'll use for illustration purposes. Here's the kind of prototyping board that you could be using for this, or the green style boards too. Basically, you have these little copper pads around holes. The component that you're using, like this diode, goes into the hole. You solder it on this end, and then you clip the end flush. Because I'm going to keep using this diode in the future, I'm going to use this piece of scrap board I have, and then normally you would stick the component in, you know, as far as you need to. You would often bend it like so, and then put it through two holes, the appropriate holes in the board that you're working with, and insert it in so it's flat like that. Then you turn it over and solder, snip, cut them both flush. I'm gonna leave it sticking out a bit though, so that I can keep using this and it won't be too short. Basically, the way you do this, okay, so I inserted the component into the circuit board. There's a little bit of extra lead sticking out above the surface, and basically I'm going to freshly wet the tip with solder, then apply it to the little pad and the component lead sticking up, and then just apply a little bit of solder. And as soon as it looks like it has wet through and fully adhered, then you're done. Take the soldering tip off. Don't try to keep reheating, or else you'll end up often burning out the component. You'll overheat the diode or whatever you're working with, and or the pad, or you'll end up with this ginormous glob of solder all over. Technically, that's maybe a little bit too much solder, so I'll try to do it a little lighter on this one here. Apply the heat, a little bit of solder, and I'm done. I'll try to get more of a clear close-up of the actual joint here. So see, on that one has a little bit much solder. It's kind of balled up and just mounded kind of high. This one is just about right, where it's sort of there's kind of a tape or a curve to it. There's just enough solder there to do the job, but not a huge glob, basically is how it goes. And then some flush cutters, which I will grab. This end of the cutters, this side is ground flush, so it'll instead of trimming the lead out a ways from the part, it'll go down as close as possible. Put your finger over to keep from spitting that little wire piece at someone's face, including yours. And you basically just trim the parts, trim the ends of the lead sticking out, and there you go. That is a completed soldered joint of a diode into a circuit board. Normally this again would be down on the surface. Alright, so the final soldering application I'm going to show is a butt type connection of wire. Say you had this wire and it was one piece, but it got accidentally cut. You need to now splice it back together. Here's a good solid way of doing that. First you strip the wire, and then basically I'm going to use some soldering paste flux. Just get it from Radio Shack. Dip the wire into the flux. You don't need a ton, a little goes a long way. Basically just make sure you have some flux on the two parts, and then I'm going to kind of shove the wires together gently, letting all of the individual strands kind of intertwine with each other. If they will go together, there. Kind of intertwine, and then I'm going to twist them a little bit and make them all lay nice and flat. So now you see we have kind of twisted the wire back together, so the strands of this piece are laying right next to and sandwiched in between the strands of this piece. So it's going to be a very mechanically strong connection, as well as a pretty low profile connection. There's not going to be a huge bump like laying one wire right next to the other like this. It's more going like this, and just so rather than like two hands next to each other like this, it's putting it like this, so it gets locked together really well, but also is lower profile. And then basically I will so there's some soldering flux in the joint, so it'll help clean all the oxides off of the copper material once it starts heating up. I'm going to clean the tip of the soldering iron on the wet sponge, put a little bit of fresh solder on the tip so it will start wetting the material right away. And then I just start applying heat to the joint. Already the solder is starting to soak into the copper, and I'll just keep feeding copper in, or solder into the local place right here where I'm heating for right now. As it keeps heating up, that'll help the heat transfer more completely to the part. And I'm pretty close to being done. I'll move the soldering iron around a little bit, maintaining contact with the wires. That's probably done. I don't need too much solder on there. Yeah, that looks pretty good. I might put a little bit more solder on, but you can kind of see the individual strands still, but you see that solder is thoroughly wetted and soaked in between every single strand, which is the idea. If you feed too much solder into this, you won't, the solder already, see where we already soaked solder into that much of the wire because it won't bend anymore. And same deal over here. We've already got solder wicked into that part of it. So I would call this one pretty good. Yeah, as I said, I might put a touch more solder there, but not much, because that's pretty good. That's mechanically sound, we're very electrically sound. It will conduct very well, and you have now fixed that wire. To complete this, you would wrap some electrical tape around this, overlapping some on the ends to insulate it, or use some heat shrink tubing, slide it in on the ends. Normally you would, if this wire wasn't accessible on both ends, you would slide the heat shrink tubing in, you solder a connection, and then once it's cool, slide the heat shrink over, overlapping, heat it, and you're done.